Caffeine support team comprised of Ashton Anderson, me, George Lee, Stephen Lewis, David Pena, and Lance Wright. We are introducing a set of robots we're calling the disaster response team of robots. We're developing a fleet of automated robots capable of responding to a wide range of environmental disasters, and they will be able to identify survivors, contain immediate dangers, move people to safety, and clear debris.
So I'm Ashlyn. The proposed robots are the aerial reconnaissance drone, the search and rescue rover, the autonomous debris clearing drone, the environmental containment drone, and the logistics drone. So the first robot is the aerial reconnaissance drone. This is going to be the eyes of the operation. There's 2 sensors on the very bottom of the drone, and then moving into the algorithm of it, you'll see here. So if any of those sensors record information, it'll be printed out and sent to the other robots. There's 3 toggle switches on the bottom that controls all 4 of those motors. So that'll control whether the drone moves up, down, side, forward. And yeah, moving on to robot 2.
Hey, I'm Steven. I designed the rescue rover. The main idea behind this robot is to deliver supplies to people in need or in danger. It has a large track system to be able to go over large obstacles, and the fins on that track system are also large to help it swim through water. This is also aided by the buoy system located on the front and the back. It also has a camera system to help identify people. And then its electronics consist of high-powered torque motors, some sensors to sense obstacles and help it back up or get out of the way of those obstacles, a stepper motor to help open its supply hatch, and also a flashing light and very loud speaker.
I'm Lance. Our third robot is the debris clearing drone. This is an autonomous drone that utilizes large tracks powered by DC motors, and it has a low center of gravity to traverse most terrain. It has a large excavator-style arm powered by a servo to remove loose or lighter debris, and a ram to move the larger, heavier debris. The robot begins with processing the location of the hazards that the aerial reconnaissance drone has indicated. And on its way, if it runs into an object, it will attempt to remove it first with the arm, then the ram. If it cannot, it will reroute and proceed to the target location.
Next, we have the environmental containment drone. As the name implies, its intended use is to surround any chemical spills or any dangerous chemicals and contain them with a chemical containing boom. The algorithm for this is that it starts off for operations by scanning its surroundings with a hydrocarbon sensor, which we simulate with a photoresistor cell. And if it detects dangerous chemicals, it deploys a chemical containing boom with an actuator, and encircles the chemical until it completes a circle, and then continues to scan its surroundings with the sensor. If it does not, it moves to a location at the end of its scanning range and continues to scan. And next we have the logistics drone. And the idea with this one is that we needed a drone that was able to deliver life-saving materials and first aid material to survivors. It was able to do this through the winch that you can see in the center of the drone. And it was able to find appropriate landing zones with its camera and ultrasonic distance sensor.
So as we can see in these photos, each drone is doing its individual job and helping or moving something, as we can see in the video. So the video shows the aerial reconnaissance drone scanning the area for survivors, dangers. Then the logistics drone dropping off supplies for our survivor, which is the penguin. Our next drone clearing the flames. Then our fourth drone will be clearing treeway for our survivor and the rescue rover. The rescue rover will go and deliver supplies, and then the survivor will make his way to freedom.
Our 5 robots are better at solving the customer's needs by usability for any environmental disaster. Robots that share sensing, communications, and logistic tools and reduce the number of vehicles required per mission. It also lowers procurement cost per capability. So together, these robots are more efficient, safer, and a cheaper alternative that will greatly improve one's ability to respond to environmental emergencies.